All right, so hi everyone. In this video, what I'm going to do is determine the steps that we're going to need to follow when we're performing a hypothesis test. And then I'm going to do another example given the hypothesis test that we started talking about last time. All right, so here we go. In this class, we're going to follow the next steps to do a hypothesis test. So to do a hypothesis test, which is the thing that we started talking about last time, we're going to always follow the same steps, which is to first formulate a null hypothesis, which we're going to call H0 every time, or H0, and an alternative hypothesis, which I call every time HA. And the idea of formulating a null hypothesis and an alternative hypothesis is that the null hypothesis is the thing that I'm going to try to disprove by contradicting it with evidence that supports the alternative hypothesis, right? So what I am always going to do is to assume that the null hypothesis is true. So that means I'm going to assume that a mean is equal to a certain value. And then if my data shows evidence that contradicts that null hypothesis, then I'll be able to say that the alternative hypothesis is actually a pretty reasonable explanation why the null hypothesis is false, right? So I start by assuming that this is true, and what I'm trying to do with the data is contradict that null hypothesis. The second thing that we are always going to do is to decide what the level of significance is. So decide what the level of significance is going to be. And actually, level of significance, this is called alpha. But in most of our problems, this is actually going to be a given value. So this is going to be given, and so you'll just have to copy the value that is given in the problem. Now, if the value is not given, which is going to be the case in the research project, for example, you'll be able to decide what the level of significance is going to be, depending on how strong you need your conclusion, right? So what we said is, the level of significance is pretty small. That means that we're going to need a lot of very strong evidence in order to contradict our null hypothesis. Whereas if we're a little bit more relaxed with the value of the level of significance, that means if the level of significance is a little bit larger, then that means we're going to allow, we're going to let ourselves be contradicted without the need for such extreme evidence. And the third step is the bulk of what we're going to be doing. So that's what I'm going to call perform the hypothesis test. And this is going to be divided into several steps, which are always going to be followed in the same way. So to perform the hypothesis test, we're going to have to first decide which test to use. So that just means that we're going to have to verify that the assumptions to use our test are satisfied. Now, this is the same thing that we had for confidence intervals, which is that we can only use the tests that we know if a certain number of assumptions are satisfied. Only then is our conclusion valid, right? So the first part that we have to do over here, we have to verify that those assumptions are verified. Okay, so the conditions that we have set are verified. The second thing is we need to find the critical value. And you saw this on Thursday, you always have a way to find the critical value that is given by the test itself. You'll always have access to this. But the way that you can understand the critical value every single time is the boundary between the usual and the extreme, right? So the critical value is that number that separates the things that are usual from the things that are extreme. The third thing is to find our test statistic. So find the test statistic, which means from the values of our sample, we're going to determine what the number that characterizes our sample is going to be. And that is the number that I am going to end up comparing to the critical value. And so that's the thing that I'm going to try to determine whether it is usual or whether it is extreme. And finally, the last step over here is going to be to conclude and interpret the result. So what that means is that if our test statistic falls in the extreme region, we will conclude that the null hypothesis is false. And so we say, in these cases, that we reject the null hypothesis. Right? So again, the logic for this is the following. You have assumed that the null hypothesis is true, then based on that null hypothesis, based on what we assumed that was true, we're going to determine what we should have expected, the usual, and what is pretty rare based on that hypothesis, what's extreme, right? Then we look at what happened with our sample, and if it turns out that what happened with our sample is extreme, then that means that it probably is not just out of randomness that result occurred, and so the null hypothesis is most likely not a viable explanation for having gotten such an extreme result, right? So the idea is, if my result is extreme, then it's probably because my original hypothesis was wrong, right? So the idea is, I assume that this is the explanation for all of my data, and then if my data cannot really be explained by that assumption, then that must mean that the assumption that I made originally must have been false. Okay, so that's the idea between everything that we're going to do with hypothesis tests. In order to get a little bit more practice on this, I'm going to do a second example. And maybe with this in hand, you can go back to the first example that we did and try to reread it and understand the logic again. So here's the second example that we're going to talk about. We have that soap powder is sold in boxes of 3 pounds, and a factory manager wants to verify that the machine filling the boxes has been set to the correct setting. He finds that the mean and the standard deviation from 8 3-pound boxes are 3.1 and 0.11 respectively. So that means the mean is 3.1 and the standard deviation is 0.11. We also are given that the distribution is approximately normal. The first question that we're going to have to answer is whether there is enough evidence to claim that the machine is overfilling the boxes, and this word overfilling is actually going to be important for us, using a level of significance of 5%. And then we are going to have that, the second question is going to be to determine how likely our observation was. So I'll elaborate on this a little bit afterwards. So let's begin with the first question, of course. And a big part of doing a hypothesis test is to be able to read the problem properly and identify the information that you've been given. So that should always be your first reflex. You just do an inventory of all the information that you were given, and based on that, it will become a lot more clear what test you need to do and what pieces go into that test. Okay, so the first thing that I'm going to look at is the fact that this manager collected data from 8 boxes, right? So we had 8 3-pound boxes. So this means that the data was collected only from 8 elements. So this is going to tell us what the sample size is going to be. The next thing that we're told is that there's these values of 3.1 and 0.11, and the value of 3.1 corresponds to the mean, and the value of 0.11 corresponds to the standard deviation. And of course, these are the mean and the standard deviation from only those 8 3-pound boxes, which means that these are both sample values, right? So this is the sample mean and this is the sample standard deviation. And finally, you are given that we're going to have to use a significance level of 5%. So this is what I meant before by the significance level is always going to be given. Here's what I had, right? I said, decide what the level of significance is, and this is what I mean. This value is usually given in the problem that you're doing. So here we go. With that information, inventory. I'm going to start writing down those values. So the first thing is I have 8 over here. That 8 means that the sample size is equal to 8. Then I have that the mean is 3.1, but the mean is 3.1 for these 8 3-pound boxes, right? So that means that X bar, my sample mean, is equal to 3.1. Then I'll have that the standard deviation is equal to 0.11. But again, that is the standard deviation from the 8 3-pound boxes. So that means that S is equal to 0.11. And finally, I was given that the significance level that we're going to have to use is going to be alpha, which is equal to 0.05. Or you can also write this as 5%. Both of those ways work. Okay? So here's our list of information, and now we're going to have to follow the steps that we have to do the hypothesis test. So the first thing that we need to determine is the null hypothesis and the alternative hypothesis, which means that the thing that I want to disprove versus the thing that I'm actually trying to prove, right? So I'm going to have to come up with the null hypothesis, what I'm trying to disprove, and what I'm trying to prove. Okay. Now here, I'm asked to determine whether there is enough evidence to claim that the machine is overfilling the boxes, right? So that means I need to determine if the machine is filling the boxes with more than 3 pounds, right? Because the machine should be filling these boxes with 3 pounds of soap. And if I'm trying to determine whether the machine is overfilling that, then that means I'm trying to determine if the setting for the machine is more than 3, right? So that means that the parameter that I'm looking at is going to be a mean, which is the average weight for the boxes, and the alternative hypothesis is what I'm trying to prove. So I'm trying to show that there is a difference. I'm trying to find evidence that would contradict the idea that the boxes contain 3 pounds, right? So the alternative hypothesis, the thing for which I will have to show evidence, is that this average is actually larger than 3. So that the mean weight, the average weight, is larger than 3. And so that means that the hypothesis that I'm going to be contradicting is the nothing happening, which means that mu is equal to 3, that the average weight is actually equal to 3, okay? Now be really careful not to get confused. This is a comparison value. This is the value that I'm comparing the mean to. This value over here is the one that I got from the sample, and this is not the same. What I'm trying to do here is to compare this average to 3, and then based on the sample, based on the information that I got from our sample, I'll be able to determine whether this is actually significantly larger than 3, okay? So this is my null hypothesis, this is my alternative hypothesis. That means that my first step has been completed here. This is the thing that I'm assuming to be true, and this is the thing that I'm going to try to conclude. The second thing that I'm going to do is to find the significance levels. That's our second step. Decide what the significance level or level of significance is. But in this case, the level of significance is already given, and we already know that that's alpha equal to 0.05 or 5%. Okay, so that's, again, not too bad. The third thing is to actually perform the test. So the first step here is going to be to determine the type of test that we're going to use. And because here we're given that the distribution that this comes from is approximately normal, and also, you know, and this is just between us, because this is the only test that we have seen so far, then you know that that's the one that you need to use, right? So we're going to use the one sample t. one sample t-test, which means you can go back to your notes and the test statistic is going to be given there, as well as the way to find the critical numbers, which is incidentally is the next step. So we're going to have to find the critical value. The critical value is going to be the value that separates what's usual from what's extreme, right? So that means that my distribution, which looks like this, is going to have some values that are going to be considered usual and some values that are going to be considered unusual. Now, because I'm trying to show that my mean is larger than 3, then I'm only going to look at the larger part of my distribution, which means the part on the right. If this were smaller then we would be looking at the values on the other side. But here we're looking at the values on the right because we're trying to demonstrate that mu is larger than. So my value should look something like this. It should be the boundary that separates this top certain percent from the bottom another certain percent. Now, what percentages are here? That depends on the level of significance, right? So if my level of significance is 5%, that means that I will conclude that the extreme is extreme if it's in the top 5%, right? So here we'll have that this is 95%. Okay? Now remember, warning over here, this is a t-distribution, which means that I'm going to have to go to the t-table. I'm going to look for t of 0.05. And here I'm going to put this in red. I'm going to look for the row that corresponds to n minus 1, right? So in this case, that's equal to 7. So I'm going to have to look at the row that's equal to 7, which corresponds to the degrees of freedom, okay? So now that we're here, let me go to the t-table that we have for this. So here we go. What we're looking for is the, let's see, so we're looking for the row with 7 over here. So I know that that's the row that I'm going to be looking at. And in this case, I'm performing a test that is one-tailed, right? Why one-tailed? Because I'm trying to just chop the top part of the distribution, right? That's because I'm trying to show that the mean is larger, not different, just larger than a given value. And because of that, I'm going to go on the line over here that says one-tailed to the piece that says 0.05. So this one over here, right? So on one tail, I have 0.05 over here. And so I know that I need to look at this column, this row, and I end up with this value over here, 1.895. Okay, so this is going to be my critical value, and I can go back now to my piece of paper normally and decide, okay, well, it looks like the value that separates the top 5% from the bottom 95%, because it's just one tail, right? So I'm just chopping this from one side. I looked at the row that corresponded to 7, so 8 minus 1, n minus 1, and that gave me that this value was equal to 1.895. Okay, so this value over here, my critical value, is 1.895. So before I move any further, what that means is that I will reject my null hypothesis. I will say, actually, the mean cannot possibly be equal to 3 if the value that I found for my sample is larger than this number, right? Because that would mean that what I predicted to be normal, which is any value that is less than 1.895, did not correspond to what I saw in my sample. But if I have from my sample a value that is smaller than 1.895, then that means that my sample actually corresponds pretty well to what I should expect based on my original assumption. So in C, I'm going to have to evaluate T. And this is given, again, in your notes. The test statistic, I'll just write this, test statistic is going to be T, which is equal to X bar minus the comparison value. So I say mu naught in general, this is just a label for it, but in this case, my comparison value is 3, right? So comparison value is the value that I'm comparing my mean to, divided by the standard deviation over square root of n. And now by replacing the values that I already know, I know that this is going to be x bar, which is 3.1, minus 3, divided by 0.11 over square root of 8, right? My sample size. You can evaluate this using your calculators, and you'll find that this is 2.57. And finally, we can go to step D over here. We found that 2.57, maybe I'll label that with a little stamp over here. I have that 2.57 is going to be actually pretty high in my distribution. That means that it's quite a bit higher than 1.895, which means that it is going to correspond to the rare side of my distribution, right? So remember, the extreme part over here, this is the extreme side, whereas this is the usual side. So this is what I would expect most of the time, whereas this is what I would expect only on extreme cases, and so what is most likely not caused by our original assumption. And so because 2.57, our test statistic, is larger than 1.895, which is a critical value, that means that our value is too extreme to be explained by our original hypothesis, right? Explained by the null hypothesis. That means by a setting in which the average weight is actually equal to 3, which means that I will have to reject the null hypothesis. Okay, so the fact that I'm rejecting the null hypothesis means that I am so using a level of significance of 5%, I'm able to say that there is enough evidence. There is enough evidence and here I have to be very careful to be explicit about what the level of significance is, with alpha equal to 5%, to conclude, to reject the null hypothesis, which means that most likely the machine is overfilling. The machine seems to be overfilling the boxes. Right? So what does that mean? Our sample size over here told us that our sample mean told us that the average weight of my 8 3-pound boxes was actually above 3 pounds. And what we said is, okay, this doesn't look like that much of a difference, but maybe because the standard deviation is so small, there might actually be something wrong. So my machine might be set to a setting that is a little bit higher than 3 pounds. And so each one of the boxes is being overfilled by a little bit. Right? The machine seems to be overfilling the boxes, and we know that the level of significance for this is 5%. It's really, really important to specify the level of significance because this is telling your reader, whoever's reading your solution, that you know that you require just enough evidence to have a confidence of 95% that you got the right answer, right? So if your level of significance were a little bit smaller, let's say 1% or 0.05%, then your reader would know that the result that you got is even more reliable because you were requiring more evidence to begin with and you still got to the same conclusion. Here we weren't requiring that much evidence. We only had a level of significance of 5%. Which brings me to the second question. Okay, so this is all to answer the first question. We're here. And I'm just going to answer the second question over here, which is, what can you say about how likely your observation was? Okay, so this is, maybe it's a little bit ambiguous, but it should give us an idea of what's going on. So the idea of this result, of the way that we're conducting our hypothesis test, is that assuming, so like we assumed from the beginning, remember we always assume that H naught is true. What we are saying is that our result was in the 5% more extreme cases, right? It was actually a little bit above that. And so that means that my result would have happened less than 5% of the chance of the time, right? So our result, our result or a sample mean would have been this high. So that means a value of 3.1 or higher, less than 5% of the time. 5% of the time. So that means that if my average weight for the boxes were actually equal to 3, and a sample average as large as 3.1 pounds for a sample of 8 boxes would have only occurred less than 5% of the time. So only for less than 5% of the samples that I could have gotten from a population whose mean is actually 3 would I have gotten such a high result. Now, because that happens so rarely, less than 5% of the time, then I can say, okay, well, this is actually a pretty unlikely result. And so most likely my initial assumption was wrong. And so that means that the initial assumption was wrong. Which is why I can say that I reject that initial assumption. It is not a satisfying explanation for the extreme result that I got. Right? So this is the way in which we're going to solve all hypothesis tests problems. We're going to have different hypothesis tests for different scenarios, but the steps are always going to be the same. So that means we're always going to have an assumption that we start with, an assumption that is going to contradict that, which is usually what we're trying to show. We're going to have to set a level of significance to determine how much evidence we want to be shown before we conclude, before we contradict our initial hypothesis. And then we're going to have to set a boundary between what's usual and what's unusual and see whether our sample fell in the usual region or the unusual. Always the same steps. Make sure that you keep track of those core principles, and then everything else is just applications of formulas, which you will always have near you. Okay? As I said, I'll post 2 problems that you can practice before Tuesday, and then we're going to start complicating things. So I really, really suggest that you practice these beforehand. See you then.